Good afternoon, all of you. And today, this afternoon, now we are discussing about the opportunity to address risks for crop using crop simulation model and prepare appropriate advisory. Whatever the results we are getting from the model simulation, that information we have to use in preparation of advisory. That is the important. So once we simulate the model and getting the results and keeping in the desk has no meaning. So the information we have to pass to the farmers in the form of advisory. So that is important. So on this regard, now we will discuss. So regarding the various risks associated with the crop production and how we prepare the advisory and how it will reaching the farmers to take up the action at his farm level. So first of all, I am Dr. G. Srinivas. I am at senior professor cadre and presently heading at Regional Agriculture Research Station, Jagityal in Professor Jayashankar, Telangana State Agricultural University. So basically, I'm agronomist, and out of 30 years, I worked in the field of agrometrology. So I'm a trained agrometrologist with an agronomy background. I have attended a number of training programs in the field of agrometrology, crop modeling, remote sensing, GIS, and water management. So based on that experience, I have guided a number of students on remote sensing, GIS, and modeling. And presently also one of the student, presently I am guiding 3 PhD students, all are in the crop modeling and remote sensing. And one of the student, he was the MS student from this campus. Maybe in 2019, he has completed Tarun Kumar. This from this campus only. He has done research on organic farming or something. Now he is my PhD student. He is doing the similar kind of work, just like Mronalini has done. No? So we are identifying the remunerative cropping across the locations in Telangana state by using remote sensing and crop simulation modeling for alternate to Rabi rice. So main object is to diversify the Rabi rice. In that direction, he is working. So now in my presentation, now we will discuss about the what are the various risks associated with the crop production. Okay, fine. Now you see the number of risks associated with the crop production. So first of all, what are the risks associated with the crop production which are being faced by the farming community? If you see climate risk, so ultimate the results in the reduction in the crop yield. So climate is the major risk that we know that now we have been experiencing the variations in the climate and climate change. Nowadays, everybody is talking about the climate change. So our aim is mainly to address the variability of climate that we have been experiencing year after year. So the climate change is a very long-term period of average weather, different weather parameters. At least now, instead of addressing the climate change, we have to address the climate variability so that we can stabilize the yields or enhance the productivity of the crops. And one of the major risks associated with the crop production is pest and disease, because now if you see the variations in the climate, it may be variation in the temperatures or relative humidity and variations in the other weather elements. So mainly it triggers the occurrence or incidence of the pest and diseases. In last 20 years back, some of the minor pests now they have become major pests. So like that, different crops are affected by the new pests and the cost of inputs. So year after year, because of variations in the market price and the so many regions, and not only in India, across the globe also, there is a lot of variations in the input cost. So that there will be a finally farmers they are incurring the huge amount on cultivation of the crops, and finally the net returns will be reducing, and market prices is also highly variable nowadays. At the time of sowing, farmers they are expecting some market price, and accordingly, if the market price is prevailing at a higher level, they will choose the some crop. But at the time of harvest and when the produce transported to the market, automatically there will be a reduction in the market price. Again, there is a huge risk for the farmer. Ultimately, the reduction in the net returns. So storage risk is also there. Nowadays, farmers they are storing the produce the farm itself, and because of the poor market price, whenever they shifted the produce to the market, there will be a loss. So for that, government has to provide a very good infrastructure facilities to store the farm produce at different districts or block levels. And how the farmers they are coping the various kinds of risk. There are two kinds of situation. One is a strategic and a tactical. Strategic, tactical means after sowing the crop to time, what are the decisions to be taken depending upon the conditions prevailed. For example, once a crop is sown, in between there will be some dry spell. Then what are the decisions to be taken to protect the crop? So there's those decisions we can call it as a tactical. And strategic means before sowing the crop or long-term planning at farm level, those are the strategic decisions. So under this tactical decisions, time of planting is very much important. That depends upon again its onset of monsoon, availability of labor, availability of inputs or finance. So all these factors influence the time of sowing. So the time of sowing is very much important. So it has its a significant contribution to increase the crop yield. So normally for any crop, if you sow during the optimum sowing window, then only we will get the good yields. If you sow the crop either too early or late or beyond the sowing window, definitely there will be a considerable reduction in the yield. That you know very well, many agronomy students and other crop production students. And the selection of crop types. And this mainly depends upon the long range weather forecast. Farmers they select the crops based on their historical or previous experience. But if they consider the crop selection based on the long range forecasts, the long range forecast will be given by the IMD during the month of April and June. So if the farmer they understand the long range forecast, how the season is going to be, whether it is going to be a wet or dry or drought, so accordingly they have to select the crop. Suppose there will be a drought condition, a low rainfall year, then within the drought tolerant crops, they have to choose the varieties which are still more drought tolerant. Suppose cotton is a drought tolerant, that we know very well. Within the cotton also, some of the varieties are more drought tolerant compared to the others. So under those situations, farmers they have to select the varieties which are more drought tolerant to minimize the risk of drought. And in season adjustment of inputs, fertilizers, fungicides, pesticides, labor, herbicides like that. Because once the crop is sown, in between, if there is a dry spell or excess rainfall or a severe outbreak of pest and disease, like that, some number of risks are there. If you consider the season as one of the risk like drought, farmers they have to apply the less amount of the fertilizer. Under reduced amount of soil moisture or limited amount of soil moisture, if you apply the more inputs, so crop will not give more yield. So we should not think that if even though moisture is less, if you put more fertilizer, we cannot expect more yield. Instead of increasing the yields will be decreased. The amount of moisture available in the soil will be depleted very rapidly compared to the normal. So that you have to keep it in the mind. Under reduced amount of soil moisture or drought conditions, we have to minimize the inputs. So here we have to keep it in mind. Under normal and good rainfall years, we have to invest more and harvest more. Under abnormal years or low rainfall years, invest less and minimize the risk. And at least we have to overcome the loss. So that is the kind of situation we have to keep it in mind. And if you see the strategic that I told, long term plannings. So for this, mainly redesigning of the farming systems, depending upon the resources and the uh, historical weather data analysis, the results of the historical weather data, and also forecast rain weather forecast like this. So here we have to analyze the historical weather forecast. For that, we have to analyze the when sowing season starts and likely occurrence of the 2 to 3 weeks or 3 to 4 weeks of dry spell or excess rainfall periods. And these extreme periods, whether it is coinciding with the crop critical stages or not. If it is coinciding with the critical stages, how to shift the sowing window, that is sowing dates. So whether prepone the sowing or delay the sowing. So that kind of strategic information is required. For that, we need to analyze the data with our crop yields with the modeled scenarios. We have to run that models by taking the 30 years weather data and we have to run the simulations. We have to get the results and analyze. So what are the periods? Crop critical stage is coinciding or drought period is coinciding which critical pages, whether it is coinciding with the flowering period or grain filling period if it is a cereal crop, or if it is a indeterminate crop, whether it is flowering or any other critical growth period. Like that, we have to analyze the and assess the risk of that crop. And co-design the farm systems for resilience and market opportunities. Market opportunities, of course, it is not in our hand. Wherever the crop requirement or demand is more, there we have to plan the crop. So nowadays, some innovative farmers, they always try to introduce new crops or new way of cultivation or new varieties. They're always in forefront to introduce the new technologies or innovations. Now these farmers are also going through the internet or YouTube channels and getting the technological information. They are always in the forefront to introduce the other farmers. So based on that, we have to redesign, and first of all, we have to test the technology at a smaller area or micro level. Then after, once it is validated, we have to expand to the larger areas. Infrastructure and institutions to enhance the adaptive capacity. Infrastructure facilities, farmers need financial support or input support for the purchase of or procurement of the inputs, and marketing facilities, infrastructure facilities to store the produce. Like that, the number of facilities are required. So accordingly, farmers, they have to plan the redesign the farming situations. These are the some of the strategic stat information. So this is regarding our state. Here in my presentation, all examples are from our state only, and just try to understand the concept. And in our state, we have three agroclimatic zones: Northern Telangana, Central Telangana, and Southern Telangana. So three regions are different rainfall patterns, temperature patterns, soil types. So now if you see, the top one is the Northern Telangana zone. If you see the rainfall variability, this is the long period average. So minimum rainfall in all the years is 753 mm, maximum is 1516. Almost you see the double, minimum to maximum double. The variation is that much variation. That means certain years less rainfall, certain years more rainfall, depending upon the soil type. If it is a high rain in heavy soils, there we need to provide the drainage. If it is a light soils, so in low rainfall years, we have to take the appropriate measures to protect the crop during the dry conditions. Like that, we have to plan the uh, program. And in Central Telangana, this is the 682 is the minimum and maximum is 1275. So there is a lot of variation between the zones also. Northern Telangana region is a high rainfall region. Central is the medium, and Southern Telangana is a low rainfall region. Unfortunately, in Southern Telangana region, soils are also very light, where normally the millet crops, low value crops will be grown. In Northern Telangana, high rainfall region, that is a Godavari area. We have a good canal system. In Southern Telangana, Central Telangana is the Krishna River basin canals are there. So this year, and in Northern Telangana, we have plenty of rainfall. But in Southern Telangana, no rainfall. It's a drought kind of situation within the state. So one part of the state is experiencing the good rainfall situation, and other part is experiencing drought. So that is the kind of situation. So accordingly, according to the region and the soils, climate point of view. So as a crop production scientist, we have to plan the programs. And the major issue is the rain-fed farmer. Irrigated farmer, anyhow, the risks may be there, but relatively less compared to the rain-fed farmer. So for rain-fed farmer, when to sow the rain-fed crop? So in rain-fed region, rainfall will be less. Highly that erratic distribution will be there. Soils are also very poor in water holding capacity and nutrient retention capacity. That we know. I need not to tell Ryland agriculture again here. So he should not lose the seeds. Nowadays, every farmer is depending to get the seed from the market only at the time of sowing of the crop. So they are spending huge amount on hybrid seeds, and farmer has to sow the crops whenever the optimal soil moisture is there. Otherwise, in the suboptimal moisture conditions, if he sow the crop, germination will be affected. Again, he has to resow by procuring the seed. Again, he has to invest. So it is a very risk to the rain-fed farmer. Irrigated farmer, they can give the irrigation if dry spell occurs. So we know very well at the time of onset of monsoon, radiation will be high, high evaporation, high temperatures, break in the monsoon, like that. The rainfall, the onset criteria is different from IMD criteria is different, but for agronomist farmer, it is different. IMD people, what they will say, they say the continuously 2 days, 2.5 mm of rainfall is required. 60% of the rain gauge stations in a given region, then they will declare they have their own criteria. But that criteria may not hold good for the agriculture scientist or farmer. So we need at least if you sow the crop beginning of the season, seed has to germinate, crop has to establish. Even after emergence of the seedling from the soil, out of the if it comes out of the soil, at least it has to sustain for 1 to 2 weeks. Even dry spell occurs. So that is the condition. Rainfall or minimum rainfall is required to sow the crop in the rainfed situations. And how when to control the pest. That is because rainfed farmer is always poor in financial position. So he requires when to control. He has to see whether the damage is above the economic threshold levels or not required to spray or whether required to spray. So what type of pesticide has to select? If you select one pesticide, yeah, it should have multiple effects or multiple number of pests. So broad spectrum of control, like the more number of sucking pests or bollworms like that. So he has to see all these things and when to apply inputs. I told just so whenever optimum soil moisture is there, then only if you apply the inputs, the use efficiency will be more. Otherwise, the reduction will be there. So that is the when to harvest the crop. This is a very crucial for the rainfed farmer because he will grow crop will be grown for 3.5 months to 4 months. All of a sudden, if there is a that is a cyclones or depressions developed in the nearby sea and it will devastate the entire crop. So immediately farmers, the total loss will be there. In farmer, they have to always listen or department officials or scientists or extension people, they have to advise the farmers time to time to reduce the risk of such kind of low pressures or depressions. Otherwise, total crop loss will be there. But he will expect a good harvest. Instead of that, the total loss will be there. So there is a greater risk. So these are the various kinds of risk associated. So how to overcome the risk when to sow the crop? For that, we have tested some criteria by using the models. The beginning itself, I told in my presentation, how to overcome the risk by using the models and advisories. So this is the one of the criteria we tested and validated with the in the farmers field. So under this, now you see, so whenever the soil moisture start, but means whenever the soil moisture up to 15 centimeters depth is optimum level or field capacity or above 60%, then only if you sow the crop, the germination will be occur. So based on this, we have see the maximum number of possibility of the sowings or minimum crop failure. That kind of criteria we have tested. Based on this model results, we have tested the so we have developed the one sowing rule. One sowing rule. That means for light soils, for black soils, sowing rule will be different because light soils requires less amount of rainfall to plow the field and to sow the seed. So for light soils, after onset of monsoons for a given region, continuously or consecutively for a within a 1 week period, if rainfall accumulates 50 to 60 mm, then only rain-fed crop has to be sown. The same in case of heavy soils. So the amount of rainfall should be 60 to 75 mm continuously for the 1 week. Within the time period, a time span of 1 week, the rainfall accumulation should be 50 to 60 mm for light soils and for heavy soils 60 to 75 mm. This sowing rule will be applicable only for the month of June up to end of the June. And after that, we are not advising the farmers to follow the sowing rule because by the time rain-fed crop sowings will be delayed. So by the time, because of the reduced temperature, increased relative humidity, even then rainfall is not received sufficient mm for a given region, but here and there some showers will be there. So temperatures will be reduced in the first week of July. So in spite of this, for even 30-40 mm rainfall accumulation also, we are advising the farmers to go for the sowing. Otherwise, season will be getting delayed and ultimately it affects the yield. And the terminal stress also will be another problem if sowings are delayed during the Kharif season. So that enables the better germination and emergence of the crop. So better crop establishment is very much important for rain-fed crop, rain-fed farmer. So if sufficient population or optimum population is not established, there will be a definite yield reduction will be there. We cannot compensate the yield reduction in the plant population. The loss in yield due to less plant population, we cannot compensate the yield even if you adopt the best management practices. The plant is required to produce the yield. If plant is not there, instead of 6 or 7, if you take the maize crop for unit area, Instead of 6 or 7 plants per unit area, if you maintain 4 or 5, so 2 crops are missing. We cannot compensate that yield loss due to the better management practices even after during the crop season. So that is the kind of situation. And for a given region, we can see the rainfall is the unique every year. The similar pattern we cannot observe every year. So we have observed 4 different patterns. So based on the historical data. So initially normal onset will be there as per our the normal data of onset that cumulative rainfall is good to take up sowing. And by end of the season, normal season will be there. So this occurred in 1975, this kind of situation at Rajendra Nagar in Hyderabad. So this is from our database. So that means farmers, they have to practice as per the recommended practices by the university. They have to adapt to regular practices. Normal onset will be there, well distribution is there, and by end of the season also normal end will be there. If you see the second layer, right side graph, so this kind of pattern occurred in 1973. Initially normal onset will be there, followed by dry spell. There is a continuously 4 weeks dry spell will be there. This continuously 4 weeks dry spell during the crop season, and at the later end, normal season end. This is the normal rainfall by end of the southwest monsoon season in this region. So that means beginning season is normal, but if you see the end, because of the high intensity rainfall in any one of the week, so season is also ending with a good rainfall. But actually for agriculture crops, what happened? There is a dry spell between the season. So the dry spell is causing the reduction in yield, or it may be affecting. If it occurs during critical stage, definitely there will be a drastic reduction in the yield. This is the one kind of risk for the rainfed crop. If irrigated farmer, they can provide one life-saving irrigation during that time, so that he will protect the crop. He can harvest the normal yield. For rainfed farmer, there may not be a source of irrigation. So another set is in 1985 it occurred. Initially high rainfall beginning of the season, but at later dry finish. That means deficit rainfall. So initially, if you see sudden jump in there, more than 100, even 150 rainfall is there by 9th June. But if you see, there is a dry spell in between, and at the end of the season also dry. Rainfall is less compared to that end of the season normal rainfall. So this is the one kind of situation. So under this kind of situations, what are the practices to be adopted by the rainfed farmers? So that we have to work out. So what are the ideal management practices for dryland farmer? And the last one is delayed onset. Here now you see delayed onset of monsoon. Here sowings will be delayed so that the expected area crops may not be sown. So this is the major worrisome for the governments. So beginning government will be in a hurry again because sowings are not taken place as per the normal area. And later now you see season ending at the by end of the season 1000 rainfall is a high wet year, but initially, rainfed crops were not sown. But later rainfall, that high amount of rainfall at later stages, that will be good for the ID crop, that paddy and other irrigated crops. So this is the various, these are the various kinds of rainfall pattern. And according to the pattern, various risks are associated to the rainfed crops. So now we have to plan how to rectify, how to overcome these kinds of risks. If technology is available, timely we have to incorporate in the agromet advisory or agro advisory or extension advisory, disseminate to the farmers through various apps or medias, anything like that. For this we have to done one thing for our all the, we have 612 mandals in our Telangana state. So normally this actually we have done during the COVID period. So our principal secretary, government department, the people they have asked, sir, only 50% of the employees are attending the rotational basis. 50% staff attending the duty and 50% are on leave because of the COVID situation. So we have limited staff facility. How to mobilize the inputs? For that, we need the regions or districts or mandals, for those mandals where the season is starting early. So we want to mobilize the inputs immediately beginning of the season. Later, wherever the region is getting delayed, there we arrange the inputs later stage. For that, we have done this analysis. We have given in time for the government to take the decisions to mobilize the inputs, and also not only for department, other input dealers, so any person who is arranging the inputs to the farmers. For 3 different agroclimatic zones, we have done for this one. And this green northern Telangana zone, by middle of the June, the conditions will become favorable to take up the sowing of rain-fed crops in northern Telangana zone. That's I told na, good soils and high rainfall region. That is the reason. And in central Telangana, comparatively less. So this is 100% or at least this one 95% by 25th of the June. That means almost 10 days delay. They can mobilize the inputs to the central Telangana region. And southern Telangana region 92% by first week of July. That means there is a clear cut difference, 1 week or 10 days difference between the zones. So delay in the conditions to become favorable to take up the sowing of the rain-fed crops. So that based on the availability of the staff, they can mobilize the inputs. So not only for the COVID period, now this they can apply to any kind of situation. And this is the map we have developed for this one. The green one, 1st June to 10th June. So these are the mandals or blocks where the conditions will become favorable to take up the sowing of rain-fed crop by the 10th of June. So like that, if you southern Telangana, if you see, this is the red region, this blue in the month of August also, first week. So with the dry region, the delayed onset of monsoon will be there normally. So in southern part of this region, this state, so we can arrange the inputs at later. Position of the inputs can be done at later stages also. So this again, after 5 years, we validated this by taking the data. And around 95%, 90% the uh, validation is showing the results are coinciding with the observed data. Actually, we have done based on the historical data, and after that, every year we have validated for 5 years. Then results are almost in accordance with that this data only. That means we can use this information for mobilization of the inputs. And again, how to identify the risk? Farmers they may not be knowing sometimes, they know, but they may not be in a position to express. They may not be think that it is the risk. So for that, we have conducted the interviews in different low rainfall region and high rainfall region. So here I am showing the one of the central Telangana region for paddy and cotton. The one of the village by gathering the farmers, individual and focused group discussions. So here, so these are the 4 criteria we have selected: delayed rainset sowing and rainset flowering, rains at milky stage and harvest for paddy crop, and the impact. If rains delayed at the time of sowing, that means transplanting in case of rice. So the impact, that means the yield reduction will be 28%. This is the information given by the farmer. And percentage of occurrence, reduction is okay, 28%. But occurrence of chance, out of 10 years, almost 3 years, out of 10 years, 3 years, this kind of situation farmers are facing. So if you multiply the impact chance, that gives the risk. So these are the numbers only. That gives. So based on the risk, we have categorized rank number 1, the second one is 2, this 3 and 4. That means highest risk is associated with the delay in the rains at the time of transplanting of rice. So once the transplanting is delayed,
Yes, lecturer.
so later what happened in this zone, the flowering or grain filling will be coinciding with the cold weather. Again, that what happens if coinciding cold weather coinciding with the grain filling, chaffy grains or pollination will be affected like that. So that's why farmers they are facing this kind of risk. And similarly, if excess rains at milky stage, but impact is 41, that means reduction in the yield is more compared to the first one. This is the highest risk, third point. But occurrence of chance is less. Out of 10 years, only 2 years they have experienced. If you see the impact, the risk is this is the number and rank is second. Out of 10 years, the more risk is associated with the delayed in the rains to take up the transplanting. And the next one is the rainfall occurrence at the time of milky stage. So the milky stage rainfall means cloudy weather will be there, then filling will be affected. That means ultimately test weight will be affected. There is the weight of individual grain. Understood? So that is the risk. Similarly for cotton also we have done. So delayed rains, these are the 5 criteria we have tested here. They have given the highest risk for the drought during the plant growth. Plant growth means here normally for rain-fed cotton farmers, they cannot apply for basal fertilizer at the time of sowing. They go for the basal fertilizer application after 15 to 20, in between 15 to 25 days. So if dry spell occurs during that time, and the farmers, they may not be in a position to apply. And 35 to 35 days onwards, square initiation will be there. If they don't apply fertilizer at the time of that between 20 25 days, 15 to 20 days, and its branching will be affected and the canopy development will be affected. Ultimately, it may not cope up at later stages. So that's why they express that is the very high risk. Like that, farmers we have collected, and this we corroborated with the actual weather data taken for the region. So almost they are matching. So like that, we have to identify the risks for various regions, and we have to corroborate with the rainfall pattern. Then, as agronomists, we have to think of what are the strategies or management practices to be adopted to overcome the risks. Similarly, if you simple parameters are available, uh, PET, rainfall, and we can calculate the water requirement PET into KC, that we know as agronomist, irrigation agronomist. You know, if you if you graph like this, now this is the time of tasseling and silking, rainfall is very less, PET and water requirement is very high. Here you can see that means crop is not meeting the water requirement. This is for Rajanagar data. That means there is a great risk is associated with this crop growth stage. Understood? So very simple. You need not take so much data. So for your rainfed crop, for your region, you take the PET and rainfall, you calculate the water requirement and just you put it on the graph. So you can identify whether what rainfall is fulfilling the crop water requirement or not. Isn't it? Simple way we can assess the risk. Now that too in maize, tasseling silking is highly sensitive to moisture stress. And similarly, now you can see, can LGP help to minimize the risk of crop failure? Definitely. LGP, length of growing period. It considers the soil water holding capacity, potential evapotranspiration, rainfall. You know that is a length of growing period. So how many days, how many weeks or length of growing period is available? If you take the duration crop with the duration fitting between the length of sowing within that length of sowing period, then you can minimize the risk. Otherwise, so instead of not following the LGP, if you select the long duration variety, then definitely there will be a terminal stress and your crop will be affected. So that is the high risk terminal stress. This we have done for different villages. These are the knot blocks, different villages. By taking the rainfall and soil water holding capacity for those villages, we have computed in selected villages. And similarly, we have done the simulations to identify the risks. So for different for the different decades, historical weather data for a given region. So to identify the risks, how to identify the risk is also very important. Instead of simply speaking risk, what kind of risk, when it occurs, whether you can able to identify the risk. So identification of risk is important. For that, we are applying we are taking the so many ways, methods or tools. So this is the just for 3 decades for the same 20th June sowing. Now you see the how the risk is varying. This is the 40% probability in the during the period 71 to 80. Actually, there is no even the risk is not more than the 40%. It is a less than 40%. Now you see the probability. So 40%, it is less than that any stage from this is the day one of the crop sowing. This is the harvesting stage, last one. And in any growth period, so the soil moisture is not below the 40% level. That means during the 70s, the rainfall was good, well distribution, that understood itself. In the second decade, now you see for 81 to 90s. Now here this stage, around 99, this period, the risk is just before maturity or during the maturity, the risk is more. What happens? Already seed hardening is completed, then it's okay. Otherwise, suppose initially if sowing is delayed, then automatically that terminal stress will be affected, wrinkled seed will be developed, and test weight will be reduced. Ultimately, yield will be reduced. Now you see in the 90th, 1991 to 2000. Now here also crop is experiencing stress here and here. That is the number of times during the growth period stages, the crop is going to be experienced more number of stresses or frequency of stress is more. That means. So like that, stress is increasing. Sorry, risk is increasing due to the moisture stress. And for that, now we have identified for different villages. So what is the probability of exceeding 50% moisture stress? So normally for rainfed crop or irrigated crop, we are scheduling the irrigation around 50 to 60% depletion of moisture. That scheduling of irrigation. So if you see that, so depletion of soil moisture below 50%, what is the probability in different years? This is based on 30 years rainfall. And now you see this is a 50% of the problem exceeding 50% moisture stress at 50% probability in different growth stages for different villages. For this is the one village. So this is a low rainfall district, low rainfall district. So here the risk is very high. Very frequently the depletion is going below 50%. So definitely crop will be affected. I will show one more slide in high rainfall region. Now you see in a Khammam district, in at least in newspapers somewhere you might have heard, is a high rainfall district. Now you see here the probability of exceeding 50% moisture stress is very less compared to the previous. Here previous graph is the lines are up to this. Now here even is 20% chances. Only the moisture levels are going 50% depletion is only 20, even not touching the 20%. That means crop is safe in this region. That crop never experienced the moisture stress in any critical growth stage. Understood? Similarly, one more region is also there, but here little bit other region. So mixed rainfall pattern. So now here you see here 20 to 30%. Here 85 means here just be during the grain hardening stage. So like that for various regions or blocks, we have to identify the risk associated with the crop critical stages. That is, then unless until we identify the risk, we cannot suggest the management practices. Now, this based on that, we have simulated for different sowing dates for the same mandals. So, optimum planting time, a strategy to improve the yield of rainfed crop, because based on the historical 30 years data we have used for model running to identify the risk, and again we have tested the model to minimize the risk by giving the by changing the date of sowing for rainfed farmer. And there are two conditions may not be always optimum. Rainfed farmer highly variable all the parameters. But in previous slides I told the optimum sowing window and sowing rule. Sowing rule also I told. But though sowing rule may not be fulfilled in every year, but sometimes early or sometimes delay. But to take up to get the better or maintain the optimum population per unit area, we have to follow the sowing window. That is required. If you don't follow the sowing rule in the month of June, definitely there will be a. Otherwise, farmer has to give some irrigation if dry spell occurs. And these are the different sowing windows, sowing dates we have done. Now, if you see at 90% probability, June 20th, it's giving the better yield, and that means stable yields. So the yields are always more than 3.5 tons at 95% probability. So that means yields never go below that level. So if delay the sowings, there will be some reduction in the yield. So like that, we can use the model to test the to identify the risk and also to assess the management of practices also. Here I am showing the data of sowing. Similarly, we can test the irrigation, nitrogen fertilizer, and spacing, plant population. In case of rice for irrigated systems, geometry, number of seedlings, like that, all agronomic practices we can assess based by taking the long-term data by using the models to minimize the risk and to adopt the better practices. Similarly, this also. So normally I told IMD will give the forecast in the month of April and June. And forecast is there. We don't know whether the forecast is going to be correct or not. Forecast is always forecast, is it not? So exact 100% realization we cannot expect, but that gives the indication. So based that indication, we have to manipulate or regulate our practices. Now here the forecast also we have tested by taking the hand cast. That means previous years what was the forecast and how our risk is, how we are going to predict the risk. And below normal rain forecast 40%, near normal 36%, and above normal 24% chances are there during the year 2004. This was the forecast given by IMD. This is the actual forecast. But this analysis we have done after the 10 year, we have taken 10 years. That means after 15, we have taken this data to assess to identify the risk. Now here you see, this is the June 18th sowing, 25th sowing, 2nd July, 19th July. If we sow the crop 19th July, and there is a lot of variation in the yield. Sometimes total yield loss is also there. Zero yield cases are also there if you delay the sowing. And this yellow bars are there now. That is the 50 percentile. Can you able to understand these graphs? Maybe some people may not. So this is the 100% of data sets from bottom to top. So under this, the yellow block is there now. That is the 50% of the data sets. The top one is the 25 percentile, bottom one is the 25 percentile. And out of these four crops, if you sow the crop on 2nd July, so this is the lowest yield. That means if you take up the sowing in on 2nd July, the yields out of 30 years, yields never go below how much? 3 point or near 3 tons per acre, 300,000 kgs. That means yields are above that only. But here, if you see this, this is the yield during the favorable years or best years. And the lower one is the worst years. So to get the more stable yields, the length of this block should be less. This horizontal line is the median yield. This is the lower yield. This is the highest yield. And that means suppose 100, if you take 100 years data, 100 years yields, if you arrange in the descending order, the top one is the highest yielder, bottom one is the lowest yield. So if you put a line in 25 years and 975, top is 25 percentile, bottom is a 25 percentile, middle is the 50 percentile. The middle one is the yellow box. So that means farmer they have to get at least in 50% of the years the expected yield or stable yields. That means the risk will be very less. So out of these four dates, if you see, this is the minimum achieving minimum risk is less, but here compared to this graph, this bar, so little bit very less, very slight reduction in the yield. That means if farmer wants to sow this on 2nd July, so the yield, the risk of achieving lower yield is less compared to the 18th June sown crop, but he has to sacrifice some yield during the good rainfall or good weather years, because the 18th June crop, the highest yield is high compared to this one. Understood? So if farmer adopt 2nd July sowing, he has to sacrifice some yield during the favorable years. But he always harvests better yields compared to the 18th June sown crop. Some farmers they may not face the risk. So they always want good yields without any risk. Under those situations, they have to select this date. Some farmers, even though risk is there, sir, we have irrigation facility, then we will go for the 18th June sown crop. Understood? So like this, we have to address the risks. And similarly, that these are the same that when the crop is experiencing the, just now I have shown for different dates, how to identify the risk. And similarly, these are the statistical analysis for the irrigated and rainfed situations. In irrigated situations, so even if you delay the sowings, but model is not capturing the cold weather conditions at the time of grain filling stage. That's why under late sown conditions also, if you provide the irrigation, it is showing the higher yields. So that is the limitation in the model. And in rainfed condition, if you see 15th June to up to this 29th June. So the on-par yields are there. Farmers, they should not go at this level because all the years may not get the 15th June onset. If onset is there, that is the right time to take up the rainfed crop. But they have to go up to 29th June also. There will not be any significant reduction in the grain yield of maize like that. And this is the same we have seen in the different dates of sowing. Now you see this and 6th July, it is giving the better yield, stable yields. Here the risk of achieving lower yield is very less. But in other dates, the risk of achieving lower yield is very high. But in these years, even under late sowing conditions also, because it is under irrigated conditions, in the good weather conditions or good years, the yields are at higher level. At this stage, no further increasing in the yield. Even 24th to 25th, the maximum yield is saturated. So yields are not further increasing. So like that, we have to give the management strategies. This is for rainfed. Some of the years yields are very less. Risk of achieving lower yield is very high. Now you see delayed sowings, the variation is very high. Once you understand the model and these, you can identify the risk. And this is based on the how the excess moisture or drought is affecting the maize. This is the impact of soil moisture stress and grain yield. So control conditions, there is no moisture stress at all. So under those situations, 6.6 tons we are achieving by simulation. Now you see this is the silking from the silking, 10 days before silking, after 10 days silking, 10 days before silking, 5 days after silking. Like that we have simulated the different scenarios. Now you see highest yield reduction. So that means before silking, 5 days before silking and 10 days after silking is more crucial for the moisture stress. If stress occurs, if moisture stress goes below 50%, then reduction will be very high. Reduction will be very high. Now you see before 10 days silking 10%, after silking 0, that means no stress occurs. That very little reduction, very little. 5 days before 10 days, very little yield reduction. That means before silking has not much influence on the reduction in the yield. After silking is very much important because silk, if you touch it, it will be that is moist conditions. If silk is dried, no pollination occurs. That one silk, it connects the one seed on the maize cob. If you remove the one silk, then automatically one grain will be lost and entire silk is receptive. Whenever the pollen falls, it will be fertilized. If silk is dried, the yield and the grain is lost. So now this is like this. So for any critical stage, before and after, we can assess the risk. And similarly, this is for future climate impact also we have done by taking the different GCM's model output of the weather, and we have done for different regions also how the future climate is impacting. Here the GFDF model, this the yield reduction is very less even under irrigated conditions also because it is showing the nearly 3 degrees increasing in the temperature by 2050 mid-century. So similarly that reflected in the yield also. So here I am not going much deeper for you, but the impact is there. So adaptation strategies. So if 5 irrigations are available for rain-fed farmer, this is the yield. This is standard deviation. Out of all irrigations, if 2 irrigations are available, that is one at 55 days. That means tasseling and silking. One at the grain filling stage, 75 days. So that if irrigation give the irrigation, this is the yield. And same 2 irrigations are available. One is at 50, this one, and here also the standard direction is also relatively less compared to this, but yields are also very high. So when to irrigate if limited number of irrigations are available. Earlier we have done the field experiments in agronomy thesis or literature. We can find a lot of information on this. So now by validating the model, calibration and validation, we can sit in the laboratory. We can do analysis to identify the risks and also strategies. And this is for in 2015 we have done real in the one of the village. So these are the different dates and crop developmental stages. This is the daily rainfall. So here there is a lot of there is a gap almost uh, that is around 1 week, sorry, 1 month rainfall. So if early sown crop coincide with the flowering stage, later at crop development stage. So like that we can identify the current year also, and based on this we can use the simulation also to assess the yield. So whenever the dry spell occurs, if you irrigate, if during the dry spell rainfall 4.5 tons, if you give the irrigation 5.4 tons yield for the what is that maize crop. So like that, based on the irrigations, if available irrigation, when to irrigate, that also we can test with the models to minimize the risk. And this is also for cotton we have done by using the EPSIM model. So normally we'll recommend 20 days or 60, 20, 60, 90 or 120 days after sowing or emergence of the crop to minimize the stress. Instead of following that kind of management practices, if you follow the irrigation schedule based on the depletion of available moisture, so the rain and the probability of getting yield is very high, the blue line. Now you see at 80% of the years or 90% of the years. So this is the yield level. If you adopt the irrigation at 20, 60, 90 and 120 days. If the same schedule irrigation, if you follow based on the depletion of available water, so this is the yield. So this is the minimum yield we will get. That means almost 2000 kg of cotton yield. So like that we have to analyze. This you AWD rice you know very well. So for that also we have done by conducting the field experiment and so always yields are always when we irrigate the crop dropping of the ponded water below 5 centimeters. That is almost just at saturated, just below saturation. So at that conditions only if you irrigate the rice field, then under AWS situation, AWD situation, we harvest the more yield compared to the other scheduling of the irrigation and it requires more irrigation, more nitrogen fertilizer also because of lots of nitrogen during the alternate wetting and drying. Because of occurrence of nitrification and denitrification, nitrogen losses are more, so that it needs more nitrogen also. Wherever the water is very limited, under those situations for rice, we apply higher levels of fertilizer if you adopt the AWD method of irrigation. And all this information we have to communicate to the farmer. For this, IMD is providing the medium range weather forecast on every Tuesday and Friday. You know very well GKMS, Gramina Krishi Mosam Seva, Agromet Advisory Project. So these are the map, right? Top one is, so we assess this, we calculate the some indices on weekly basis to generate the advisories. We assess the soil moisture or drought kind of situation by calculating the moisture adequacy index. That is the ratio of actual evapotranspiration to the potential evapotranspiration. The actual evapotranspiration will be obtained by running the climatic water balance, Tanthwaite climatic water balance. That you know very well, Tanthwaite. So that model we will run, and based on that, we will take the actual evapotranspiration and potential evapotranspiration is available. So the ratio will give the moisture adequacy indication. So particular week, whether it is a drought conditions are prevailed or not. So that information we will get with this top. Now you see the blue line, there is no drought. The blue area, blue shaded area, that region is not affected with the drought. And this bottom area is affected with the drought. And similarly, bottom one is the soil moisture index. That is the fraction of available soil moisture. So that we have calculated. So wherever the blue lines are, where green is there, there is not a drought affected area. And the bottom is drought affected area. So based on this, we have prepared the advisory. Can you read? So here, in view of the low soil moisture content and forecast for light rains at isolated places, farmers are advised to follow these. So take up intercultivation to conserve soil moisture and rain-fed crops as this is agronomic practice. And postpone the top dressing of fertilizer. That is very much important because under limited moisture conditions, if you apply the nitrogen as a top dressing, the depletion is very rapid and instead of surviving the plant for another 1 week or 10 days, the moisture will be depleted within 4 or 5 days and crop will die. That's why we have to postpone the top dressing. Understood? We should not apply. And in view of the prevailing dry weather conditions, take up control measures against sucking pest. And like that, advisories regularly we will give to the farmers. And similarly, this is also similar way. Take up sowings depending upon the rainfall, soil moisture, drought conditions. And this is information, okay, we are calculating or identifying the risk and identifying the strategies by sitting in the laboratory by using the model. But farmers, they may or may not believe. They believe their own traditional knowledge and their practice. Only they believe certain scientists if they have confidence. Persons they are visiting very frequently to their villages or contacting. So for that, what we have to do to build the confidence and to adopt the advisory, and now these are the important strategies we have to adopt. Introduce the weather knowledge to the village farmers. First of all, they have to identify, they have to develop the knowledge. Unless until they don't have the weather knowledge, they cannot understand also. Even for you people also, if you don't have any idea about weather elements or climate or risk, you can put the blank face. Similarly, farmer also, normally we will use a technical terms. We have to use the local farmer language only we have to use. And For that, we have to install one rain gauge in the village. We have to mobilize the farmers. We have to educate the farmers how to measure the rainfall, how to apply that rainfall information to the in the different farm operations. So very frequently, we have to visit and train. And farmers, we have to involve the farmers to measure the rainfall in the village itself. Like that, regular field visits are required. And agro advisories, we have to give the forecast. You arrange one register, and they have to measure the rainfall in the village in by using rain gauge. And our forecast, they have to compare. So how the forecast, to what extent the forecast accuracy is there, whether it is a 70% or 80% or anyway more deviations are there. And we have to interact with the farmers. We have to explain the situations like that. And conduct the community meetings because the requirements are vary. That is a training need sometimes. In extension KVKs, that we can call need-based trainings like that. What is the need-based? Simply they will give the statement need-based training. For example, if you sow the crop during the correct and within the sowing window, but during the growth period, suddenly there is a or excess rainfall or dry spell. I have shown how it identified. So continuously 3 4 weeks. So whenever the dry spell occurs, that is the period he has to train the farmers to how to protect the crop with available resources, whether to go for the foliar nutrition or foliar application of any 319 or to only to sustain the life of the crop, not to increase the yield. At least crop has to sustain during that growth period, that dry spell period. So that is the need of the hour for the farmer. So you need not to give the training to the irrigated farmer. They can go for the irrigation based on that available moisture or rainfall. But we have to train the rain-fed farmer how to protect the crop. That is the need-based training. If any excess rainfall is there, then how to protect the crop from the excess rainfall. So depletion of oxygen will be there, and some wilting symptoms may be noticed, so that we can apply booster dose of fertilizer after receipt of cessation of the rainfall, so that crop physiological activity will be built up. Or immediately, if rain not permitted, at least if you see the some gap of 5 to 6 hours and go for the foliar nutrition to maintain the crop physiological activity, to build the physiological activity. Otherwise, crop will die. So like that. And if you go to the village, the different groups require different kinds of training needs. So for that, we have to organize the series of training or different. Women farmers require different because their level of knowledge is different in the village. And large farmers' knowledge is different. Their input capacity, their resources are different compared to the rain-fed farmer and poor farmers, small farmers, irrigated farmers, land-leased farmers. So like that, we have to identify the farmers and we have to give the trainings or capacity building programs as per their requirements, not per as our training, our program. Understood? So once we do this, farmers they can have the confidence up on our scientists. And stakeholders meeting is also required to implement the any management strategies in the villages, district level or mandal level or block level. So we have to identify the stakeholders. So for them, what kind of training is required? So by identifying that, we have to discuss so many things at the farmers group meetings. And this is the mode of communication of advisories. Just I have shown now how the advisories appears prepared. So different apps are available nowadays. And this is the flow of information to the grassroots level, websites, SMS, newspapers, All India Radio, like that. So this is in brief about the how to identify the risks, what are the different kinds of risks, and how to overcome the risk and how to communicate the risk, communicate the advisory to the farmer to overcome the risk. So thank you one and all for your listening for almost how much time? More than half an hour, 1 hour, I think. Oh, it's fine. More than 45 minutes. First of all, I thank to the university administration for giving this opportunity to come here and conduct the Viva examination for the PhD student. And at the same time, I thank to the Dean PG office for giving this opportunity to deliver the lecture for benefit of the students. Thank you one and all. Any doubts are there, you can please. So these are the concepts you can apply, but all the data is related to our state.
So based on the risk and simple analytical data, how to extrapolate and get the results, all that. So I think you can also adopt. Some of the students are also doing the research on effect of moisture stress at different stages of maize and all that. So you can also adopt all these strategies in your research. I hope you have been benefited by this wonderful guest lecture sir has given. So he has accepted to come over here in short notice and also accepted for the guest lecture. So we thank him profusely. Sir. So thank you so much.
If you don't have any doubts, thank you one and all once again. Thank you.